Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to Learning by Solving Problems session number 1 on chapter 5 Enols, Enolates and Aldol condensation. For each of the following reactions, predict the major product or products. 2-methyl cyclohexanone with lithium diisopropylamide excess in THF tetrahydrofuran at minus 78 degrees Celsius. The 2-methyl cyclohexanone has two different type of alpha protons, hydrogens in here. Okay, so abstracting hydrogen from this carbon will lead to the formation of what we call it kinetically favored, less substituted alkene with lower activation energy. And 5% of the thermodynamically favored, more substituted enolate. We can understand that for the kinetically controlled, you need this much of activation energy. For the thermodynamically, you need that much. And since we have only temperature at minus 78 degrees Celsius, so we activate the kinetically controlled enolate. So this is a major 95%. But when we react 2-methyl cyclohexanone with LDA in THF at 25 degrees, we give enough energy to form the thermodynamically favored product, more substituted enolate 90% and the less substituted enolate 10%. The enolate species has substantial double bond character. The more highly substituted enolate double bond should predominate at equilibrium as predicted from the stabilities of substituted alkene. Now we do the same reaction, but instead of using lithium, we use potassium diisopropylamide, THF at 25. The greater ionic character of potassium enolate, because the difference between electronegativity oxygen, potassium is different from oxygen and lithium. Oxygen, potassium, more ionic, which means that it's allowed more of the carbonyl species. In case of kinetically favored product, 42 increased from the lithium. Okay, why? Because this carbonyl is more stable than this one. We have here methyl, and methyl is electron donating. Electron donating destabilize the carbonyl. The greater ionic character of potassium enolate places an increased negative charge on the alpha carbon, a condition that is disfavored by alkyl group substitution. Indeed, the stability order of substituted carbonyl is opposite to that of carbocation, thanks to the electron donating character of alkyl groups relative to hydrogen. Finally, the rate of proton removal from the alpha carbon site is decreased by alkyl substitution, probably reflecting a combination of steric hindrance by bulky base and decreased carbonyl stability. So in here is 42 kinetically favored and 58 thermodynamically favored. Allowing this compound to react with LDA and THF at minus 78 degrees Celsius gives the enolate of what we call kinetically favored species with less substitution, allowing the reaction mixture to warm. This enolate double bond will attack on the partially positive carbon of the alkyl bromide here, partially positive, kicking the Br minus out to form the octahydroazolene 41H on. Reacting this compound with potassium tertiary butoxide in tertiary butyl alcohol at room temperature allows the formation of the enolate with more substitution, which then attacks the carbon Br bond, partially positive, kicking the Br minus out and gives the compound 1-hexahydropentylene 3A1HL ethane 1 on. See you next session.